Hello guys, welcome to Tech Me Devoted. In this video, we will discuss binary search implementation in Java. So, what is binary search actually? As we have discussed in previous video, linear search. So, in linear search, we are going sequentially. But in binary search, what we will do, actually binary search finds the position of a specified value within a sorted array. First, the array where we will store or any collections if you are using, it must be sorted in case of binary search. First thing. Then, in each step, the algorithm compares the input key value with the key value of the middle element of the array. So first, what we will do, we will calculate the middle value of the array, and then the algorithm compares the input key, whatever the key value we need to search or we want to search, with that middle element of the array. Then, if the keys match, then a matching element has been found, so its index or position is returned. Otherwise, if the sort key is less than the middle element's key, suppose it is the whatever the key we want to search, if it is less than the middle element of the key, then the algorithm repeats its action and on on the sub array to the left of the middle element. Okay, so what we will take, we will take a sub array left of from the left of the middle element, and then the algorithm repeats the action, and if the input key is greater than middle, then we will take a sub array to the right. If the remaining array to be searched is reduced to 0, then the key cannot be found, obviously, in the array. Every iteration eliminates half of the remaining possibilities, right? So this makes binary searches very efficient even for a large number of items stored in array or list. We can implement binary search in, I will discuss in two methods. First is divide and conquer, and second is using recursive method. I will discuss both of method in code. So let's start. So guys, here I've created one class binary search, and this is our main method, and we will write code to implement binary search using divide and conquer method first. Okay, so as you remember in previous video, I have discussed about linear search. So what we have done, we have asked user to provide the number they want to enter, and this will be the size. Then we'll ask user to provide numbers, whatever the numbers he want to provide, which will be stored in array. Okay, if he will provide the size of the array is 10, then he needs to provide 10 elements, so we will store in that array. Then we'll ask user that to provide the search value he wants to search in that array. Okay, so this is the same thing. So I'll write code here. If you think that how I have written, so you can refer previous video for linear search. This is simple. Just we have created a scanner class. Then we have asked, we have a print statement how many numbers you want to enter. Then we'll capture this in size. Then we'll define one array, and this size will be the size of the array. Then I'll ask user to provide the numbers he want to enter means if the size will be 10, he needs to provide 10 numbers. Then we'll write a for loop. Here we will store those numbers in our array. Then we'll say ask user to enter the number they want to search. Then we will capture this number in our search value. Then we'll close the input statement. The same thing. Now is the we have to provide the logic for implement binary search in divide and conquer method. So what we will do, so we will first write a method. Okay, public static obviously int then it will be let's say some method name as binary search. Okay, then we need to provide as in argument array. First is array, int array, and then key value. Okay, int key. Okay, now what we'll write here, so first we need to find the start of the index. Let's say start of the index is obviously 0. Okay, then we'll find the end because we are going to calculate the mid value. Okay, so we need to know the end value. So end value, what will be the end value? End value will be the a dot length minus 1. Why minus 1? You know, is to start from 0, then end index will be length of the array minus 1. Okay, now what will we do? We will check in while loop. Okay, if while start is less than equal to end, okay, then this loop starts. Now here we will calculate mid value, and mid value will be calculated as start plus end divided by 2. Okay, now if we'll see here key. Okay, if key is equal to array of mid. Okay, if this we will found the key as the mid, then what we will return? We will return directly mid because we have searched already. Okay, now if now we will check if key value, key is less than what? A of mid. Okay, so we have to compare in sub array. So what will we do here? We will have to shift end value as mid minus 1 because we have to take left sub array. Okay, left from mid, so we will take mid minus 1 as the end. So this will start will be the same 0 to mid minus 1. Okay, this will be our sub array and we'll compare there. Okay, now else what we will do? Else means what? If key is greater than a of mid, then we have to take right sub array. So then we have to calculate the start value, start index. So what will be the start will be the obviously mid plus 1. Okay, mid plus 1, and here while loop ends here. So if it is not the case, then obviously that value is not there in the array, so we will return minus 1. Okay, so that's fine. So this is the logic for binary search. What we have done, we have taken a while loop and check if start is less than equal to end, then we will calculate. Okay, then we will calculate mid value. Mid will be the start plus end divided by 2. Then we will check key. If key is array in of mid index, then we will return mid. Otherwise we will check if key is less than a of mid, then we will manipulate end value, end index, and will be the mid minus 1, so that the left array will be created from 0 to index mid minus 1. Else we will manipulate start index, and start will be the mid plus 1, so that the right index from mid plus 1 to the end value will be calculated, and if it is not there, then we will return minus 1. Now what we need to do? Just we have to call this method. Okay, so let's same thing as we have discussed in linear search, we will calculate this, sorry, call this method and put the value returned from this method to index variable. So binary search, and we'll pass this array here and this search value. Okay, now we'll check if index is not equal to -1, then we'll write that this search value done. So this is our code. So let's format it so it look better. So this is the code to implement binary search using divide and conquer method. So let's run this code and we'll check. Now, how many numbers you want to enter? Suppose I want to enter 10 numbers. Remember, you have to give those 10 numbers in sorted order. If you are not giving the sorted order, then we need to write a logic here to sort this array before processing for binary search. Okay, so let's I'm not going for sorting right now, so let us give the 10 values in a sorted order. So let's 1 2 3 4 5 6 7 8 9 and 10. Now we want to search any value. Suppose I want to search 7, so I'll put 7, then 7 is found at position 6. So in this way 7 is found, 7 is searched using binary search algorithm. Now if suppose we run again, and how many numbers you want to, I will enter 5, then enter 5 number 12 13 14, sorry, we have to run it again, sorry, I have done. Okay, 5 11 12 13 14 15. Okay, enter you want to search. Suppose I want to search 19, as I know that we know that 19 is not present in our array, so the result must be not found. Okay, so 19 is not found. So in this way we have implemented binary search algorithm in Java using divide and conquer method. Now we will go for recursive method. So now we will discuss implementation of binary search algorithm using recursive method. So I have created one class binary search recursive. Sorry, I have taken I in capital, so it's not an issue, but if you we should not write this, so it's okay. So I have created this class binary search recursive, then these things will be the same as we have discussed earlier in using divide and conquer method. So it's same thing. We have to, user needs to enter the size of that array, then user needs to enter the all those numbers and the number he want to search. So I have written here. Now here we will create method, okay, for binary search, recursive binary search. So let's create one method, public static int. Okay, let's name this method as recursive binary search. Okay, search. Now here we need to pass arguments. So what we will pass here, please watch carefully. We'll pass int array. Okay, then we'll pass the starting index. Okay, then end index, and then key value. Okay, so basically thing is same, just we need to implement it another way, in recursive way. Otherwise it is same, that it is compare repetitively, first left, then left subarray, then right subarray, what we have discussed earlier. Okay, so let's implement this. How we will do this? So we'll check if start, we will pass here whatever the values we will pass, we have to pass from here, start and all those values. So we got start, then we will take start is our start index. So if start is less than end, okay, then what will we do? We will find int mid value, and here we will find mid as start plus end minus start, and minus sorry and minus start. Okay, divided by 2. Okay, so start plus, if start is suppose 0 and is 10, so what will be the mid value? 0 plus 10 minus 0 is 10 by 2, it means 5. So now we find key value. If key is less than a of mid, okay, so what we have to do there, we in earlier method we have written those things like how to get the sub array, left side and right side. Here what we will do, we will call this method only, because we are doing recursive method, so we'll call this method again by changing its argument. Okay, what we will change here, this is important and please watch carefully. So we will, array will be the same, then start will be the same, then end value will be mid. Okay, from start to, start is suppose 0, then 0 to mid value we will calculate. Okay, then key will be the same. That's it. Okay, now else if key is greater than a of mid. Okay, greater than a of mid, then here again we have to return the same method. Okay, by changing its argument. Sorry, I have put semicolon here. Okay, then we'll call this same method, we will return this same method by changing its argument. Here what will we change? Here we have changed the end, here we will change the start. So array will be same, start will be mid plus 1 means left hand side. Okay, mid to mid plus 1 means sorry again mid plus 1, then we'll pass end will be the same, and will pass the key value we want to search. So that's it. Now else what will be the case? The case is we have to return the mid value only. Okay, so if start is less than end, we will take the what, end will be the mid, we will take the left hand side array, sub array. If key is greater than mid, then we will take right hand side array, right hand side sub array, else we will return mid value only. Okay, and if this won't be the case, means if it is not found, then we will return, we will take any value like start plus 1. Okay, in minus mein. Okay, suppose 0, as we know that start index is 0, then what will be the case? 0 plus 1, same thing, it will return minus 1. Okay, now we have to call this function here, this method here. So what we will do, same thing, int index is equal to, we have to call this method recursive binary search, and we have to pass the parameter. What will be the parameter? The parameter will be the this search array. Okay, then see here, search array, then start index is 0 obviously. Then what will be the size? See here, we have written size and we have taken the input user and put the value in size variable. So we will pass this, sorry, haven't copied, let's with the size here, and then search value means key will be the, here is our search value, pass it. Okay, so in this way we call this. Now we'll check, what we will check, we'll check if our index is not equal to -1, then we'll write print that search value search value search value is okay, else not found. Okay, so here we go, we have done this. So let's run this. Before that I will before that, just I would like to say something. I have already discussed these things. Let's repeat once again that we have already method as linear search or binary search in when in collection APIs. If you are using collection APIs, then you can use those methods, but we should know these things always. So that's why I haven't used those methods and do all. So as when we will discuss collections API, then obviously I will discuss those things also. So let's first run this. Okay, how many number you want to enter? I want to enter 10 number. Okay, again sort, it should be sorted. Okay, enter, because I haven't processed sorting and all, so we need to provide sort numbers in sorted order. Okay, so let's enter 10 number, what, 12, 13, 14, 32, 53, 54, 67, 68, 89, 90. Now what you want to search? So let's say I want to search 54. So 54 is found at positions 5. We can verify here 0, 1, 2, 3, 4, 5. So this is same thing as we have discussed in divide and conquer method, but the method is different. Let's run again. Yeah, one thing I would want to point here that I have written here is minus start plus 1. So in this case, if it won't be -1, then this value will be returned, and but here it will be returned as some minus value like -4, -5, anything depend, because here we have changed the start value, right? Start value as mid +1, so start value will be changed and it will be returned some minus value. So let's we can do here like if less than -1, so we can process like that, but I will return -1 only. So So it will be that if it won't be minus 1, then it is returned that such value is found at position, else such value is not found, to demonstrate it clearly. Okay, so run this, and how many number you want to enter? I'll enter 5, then uh, any number 12, 13, 14, 15 and 16. Okay, now I want to search some values which is not present in the array. So 29 is not found. Okay, so guys, hope this is helpful, and we have discussed what is binary search, how to implement binary search using divide and conquer method and using recursive method. So guys, hope it is helpful, and it will increase your knowledge, and just implement by yourself. And if you know this, that's cool. If you don't know, or if you have anything, any doubt, or if you are using that collections and collection APIs and using the method, that is fine, but you should know this, and you should practice this too. Sometime it is asked in interview. So guys, if you have any kind of doubt, or if you want me to make some videos on any programming you want, or any important thing you consider, uh, any point of view for interview or for your knowledge, so you can comment me below, and you can subscribe this channel to get updated with all those upcoming stuffs. So thanks for watching.